Hey everybody, this is Mr. Beckstrom, and today we're going to take a look at section 4.6. This is on linear approximation and differentials. And we're really going to be looking at this idea of a linear approximation. And notice that we're using the kind of the squiggly equal sign there. That's the approximation symbol. So that means that we're not getting an exact value for this. We're just getting an approximation. And here's the idea. Let's say we're trying to find some f of x here. Look at this black line there, this curve. There's a function. So we're trying to get whatever this y value is. But for whatever reason, we're having a hard time finding that y value. Maybe it's not an easy function to solve, or maybe something crazy like that. The idea of the linear approximation is that we take a point A that's close to this value of x here, and then we draw the tangent line, or we form the tangent line along that point A. And what we're doing is we're basically then taking the y value at A, which is f of A, and we're adding the derivative of A plus the delta x, which is the change of x, to get a value that is pretty close to that f of x there. And if you notice that the closer x is to A, or A is to x, you can see that those, right here, the y value of the black curve and the y value of the red tangent line are almost the same. So the closer we get, or x gets to A, the closer we can approximate this y value, the f of x, for using this linear approximation. So this is what it is. So we're finding, or we're approximating f of x, that's the y value at x, as the linear approximation function, that's capital L of x, and that's going to be equal to f of a, the y value at some a that's close to that x that we know how to find the value of, and then plus, this is the f prime of a, right? That's the slope of the tangent line at a, times the delta x, which is right here. So that's just the difference between the two x values. That's the change in x value. So x minus a. And notice this is like a y-intercept form here, right? The slope times x minus x1 kind of deal. So that's the idea. And the farther away you get from your a, the larger the difference is, or the worse your approximation is going to be. All right, so let's go ahead and take a look at an example and see how we would use this. And then we also want to find what's the error. We're going to use our calculator to find the exact value and just to see how far off we were to it. Notice that negative 0.01 is very close to 0, and a 0 is a very easy number to work with when we're talking about sine and cosine. So if we use a equals 0, which they give us, hopefully that'll give us a y value that's pretty close to what the actual value is. So I want you to come up with the linear approximation equation here with a being equal to 0. And then I want you to plug in the value for a in there in order to get what it is. And then I want you to give me the approximate error. So go ahead, give it a try. And when you're ready, just unpause the video. Okay, now we're going to use this linear approximation equation here in order to approximate the value of the cosine of negative 0.01. And we're going to use the a value of 0 to get something that's hopefully pretty close. And then we are going to calculate the error. That's the difference, basically the percent difference from the approximation we got to what the actual value is, and we'll use our calculator for the actual value. All right, so first come up with the equation where a is equal to 0, and then we're going to plug in the x value here of negative 0.01 to actually get what that y value is approximately, and then we're going to calculate the error. So when you're, go ahead and pause it, and if you want to give it a try, when you're ready, unpause it, and we'll go through the solution. All right, so to get the linear approximation equation, what we're going to do is we need to find f of a. So remember, a is equal to 1, so f of 0, well, that's just the cosine of 0, which is going to be equal to 1. We're going to need the f prime of 0, so the f prime of 0, which is going to be equal to, remember the derivative of cosine is negative sine, so this is the negative sine of 0, which is going to be equal to 0. And then we'll leave the x in there for now to get the equation and put in the 0 for a. So our linear approximation equation is going to be equal to f of 0, which is equal to 1, plus f prime of 0, which is equal to 0 times x minus 0. So there's our equation, and that's just going to simplify to 1. So the x actually gets zeroed out in this case, and we just have this. So no matter what value of x that we get, as long as it's relatively close to our a, we should be able to approximate it to a value of 1. So yeah, there's actually nothing to plug in the second part, so the answer is 1. And then after that, we're going to calculate the error in calculator. So remember, we're going to take the approximation minus the exact. So we first need to figure out what the exact is. So the cosine of negative 0.01, we're in radians, by the way. Don't forget to change your mode to radians, because they gave us the x value here was not degrees, so that assumes radians. So this is our exact value. Notice how close to 1 that is. So to find the percent error up there, I'm going to go ahead and store this value as x. So I can use that as x. So I'm going to take the approximation, which is 1, and then subtract our exact value, which is the 0.99, which I saved as x. Enter. And then we're going to divide that by the exact value, which once again I have saved as x. And finally, we're going to multiply that by 100. And I'm going to get 0.005%. So you can see that the y value of the using that approximation is only 0.005% different than the actual value. All right, let's take a look at another one. In the next example, the x is not going to zero out there, hopefully. All right, just a moment. All right, so go ahead for this one here. This is 8 plus x raised to the negative 1/3. We're going to let our a equal 0 and our x equal negative 0.01. So first come up with the equation in terms of x, letting a equal 0. And then what we're going to do is we're going to go ahead and plug in that negative 0.01 into that linear regression equation in order to get our approximation. And then finally, we're going to approximate the error. So go ahead and give it a try, and then when you're ready, unpause, and we'll go through the solution. All right, so in order for this, we need f of a, which is f of 0. So that's going to be 8 plus 0 to the negative 1/3. So that's going to be 8 raised to the negative 1/3, because it's just 8 plus 0. And this is equal to 8, oops, wrong one, 1 over 8 to the positive 1/3, which is the cube root of 8. And the cube root of 8 is 2. Why? Because 2 times 2 times 2 is equal to 8. So this is just equal to 1/2. All right, now let's go ahead and find the derivative here. So negative 1/3, 8 plus x raised, so negative 1/3 minus 1 is negative 4/3, and then times the derivative of the inside. The derivative of the inside is just 1. It's actually not going to change it there. So this is going to be equal to, this is a negative. On top, we're going to have a 1 on the bottom, we're going to have 8 plus x to the 4/3. So I'll just write that. And with the 3 out front here from the 1/3. 8 plus x to the negative 4/3. All right, so now let's evaluate that at our a, which is 0. So that's gonna, so f prime of 0 is going to be negative 1/3 times 8 to the, that should be a positive 4/3, by the way, I don't know. That's why I brought it down to the bottom. 8 plus x raised, I am messing up like crazy here. All right, 8 plus 0 is just 8, so that's 8 raised to the 4/3. And I'll go ahead and use my calculator for that. So let me pull that over here. So 8 to the 4/3, 8 raised to the 4/3 is 16. So this is basically going to be 1/3 times 16, which is 48. So that's equal to 1/48. All right, we're getting somewhere now. So now, kind of running out of room. Let me take this thing off here. So give me some more space here. So now what we want to do is plug it all in here. So the linear approximation of x is equal to f of 0, which we've already figured out is going to be 1/2, plus f prime of 0, which is 1/, that should be a negative. Don't let me forget those negatives, people. Negative 1/48 times x minus a, so x minus 0. And so that's just going to be 1/2 minus 1/48x. All right, so this is our linear approximation equation. So now we want to find for, what was our x? Negative 0.1. So let's bring the calculator over here. And so this is going to be 1/2 minus 1/48 times negative 0.1. And that gives us 0.502083333. We can round that just to 0.502. So that's our approximate value for y, where this function here is evaluated at negative 0.1. Now let's actually evaluate it at negative 0.1. So that's going to be, I'm just going to plug it in there. So open parentheses, 8 plus a negative 0.1 is minus 0.1 raised to the negative 1/3, raised to the negative 1/3. And you can see that the actual value here still rounds to 0.502, but after that it's a little bit different. So see how close that is? So then in order to see what the percent error is, we're going to take the approximation. I'm going to go ahead and save this exact value again as my x. So it's my approximation, which is this one up here, so 0.502. I'm going to go out pretty far. 0.83333 divided by my exact value, which I saved, minus my exact value, and then we're going to divide that by our exact value, and then we're going to multiply that by 100. All right, and remember, this is all absolute values, so this should be positive. So this is only off by 0.004%. Excuse me, that's actually 0.003%. believe my rounding's off. All right, everybody. That's all I got for you today. Just takes some practice to get these. And if you see it on the test, it'll definitely be something that's pretty similar to these. All right, if you have any questions, let me know, and I hope you all have a great rest of your weekend. Thanks.